Alright, 5th grade, today we're on lesson 102, found on page 664. It is titled Subtracting Decimal Numbers Using Zeros. The objectives are found on the board. They are subtract decimal numbers using zeros, and we will also use rounding to estimate the solution to a problem. Let's look on page 665. At the way top we have our new
Rudolph,
concept.
telephone on line 1, Mrs. Rudolph.
And it says, for some subtraction problems, we need to add decimal places to perform the subtraction. If we subtract 23 hundredths from 4 hundredths, we find there's an empty space in the problem. Okay, and they are right. 4 tenths, and they're subtracting 23 hundredths from it. There's this empty space located in the hundredths place. During this lesson, we're going to learn that we can fill it in with a zero. We can subtract, we can place this zero here without changing the value of the number because we know that 4 tenths is equal to 40 hundredths. Now that we have a value in the hundredths place, we can borrow and subtract. 10 minus 3 is 7. 3 minus 1 is 1. Our decimal point gets brought straight down. We have an answer of 17 hundredths. Understanding again that we went from 4 tenths to 40 hundredths before we subtracted. Now let's look at our example number 1. Example number 1, you will write down on your answer sheets, and it says a brand X computer completed the task in 0 and 4 tenths seconds. A brand Y computer completed that same task in 0.231 fewer seconds. What time of length did the brand Y computer take to complete the task? So brand X took 4 tenths of a second. Brand Y took 231 thousandths of a second less than brand X. So we have to take brand X 4 tenths, and we have to subtract the amount of time, the amount of fewer time that it took brand Y to do it. And it took brand Y 231 thousandths less time than brand X. Now if we subtract this amount from the brand X, we will find out what our, the speed at which brand Y runs. Placing zeros in the hundredths and thousandths places so that we can now subtract. We borrow from the 4 because 0 can't subtract from 1. We get 10. Borrow from the 10, we get 9. We find that 10 minus 1 is 9. 9 minus 3 is 6. 3 minus 2 is 1. Brand Y took 169 thousandths of a second. Double check our answers. Correct. Making sure that you label it seconds for example number 1. Example number 2 is also found on the bottom of page 665. A pedometer measures the distance a person has walked. Jana is walking 3 kilometers to Rochelle's house. While waiting at a crosswalk, Jana notices that her pedometer reads 1 and 23 hundredths kilometers. What distance does Jana still need to walk to arrive at Rochelle's house? Okay, we know that there are 3 kilometers between the two houses. She's already covered this distance. So we of course need to take the total distance and subtract the distance she has already come to get our answer of how many kilometers she has remaining. Okay, we already know that the decimal point falls to the right of our last whole number, and we can substitute 2 zeros in for the tenths and the hundredths place values. Now, of course, we do borrowing because we can't subtract 0 or 3 from 0. We get 10. Borrow from our 10, we get 9. And we get 10 hundredths. 10 hundredths minus 700, or 3 hundredths is 7. 9 tenths minus 2 tenths is 7 tenths. Decimal gets brought straight down. 2 minus 1 is 1. Our answer is 1 and 77 hundredths kilometers. Again, this is for example 2. Again, don't forget to label. Okay, let's turn our pages to example 3, found on page 666. Example 3, let's do a little bit of Viking action. In 2004, the land area of Laredo, Texas was 83 4/44 square miles. In 1993, the land area was 44 square miles. So this is 04, this is 93, and in 93, the area was 44 square miles. Between 1993 and 2004, the city of Laredo added about how many square miles? All right, I just saw the word about. That means that we're going to use rounding to estimate the solution to a problem. Boom. So this is already a pretty nice number. We could round it if we'd like to, but it doesn't really look like they do in the book. Let's round to the nearest one. Okay, and when we do that, we of course have to look at the tenths place. This 4 in the tenths place tells us to round where? It tells us to round our ones place up to 84 or down to 83. It's less than 5, so we round down to 80. So we round down to 83. In 93, it was 44 miles, so we can subtract that from it. Okay, we subtract 13 minus 4 is 9. 7 minus 4 is 3. Now, I guess when you use estimation, you can round to a number that would be easily subtracted, or that would easily subtract 44 from it. It might be a little bit easier to round it to 84 just because this is an estimation, and then you would get 4 minus 4 is 0, 8 minus 4 is 4. It would be approximately 40 miles, approximately 39 miles. Either answer is acceptable because you're using estimation. We're not looking for exact answers in these particular problems where we use rounding. Okay, so if you put 40 miles squared or 39 miles squared, depending on what form of estimation and how you rounded your numbers, I guess your answer would vary according. All right, and this is what we'll write down for example 3. Okay, let's look at a few practice problems in our lesson. We'll do one regular one, and then we'll do one of those story problems, K or L. Write this down for example 4. We're going to do just practice problem A. It says 0 and 3/10 minus 0 and 15/100. All right, again, when we subtract these problems, we need to add a 0 to 3/10 to make it 30/100, just to give us, again, some value to work with. We subtract 0 minus 5, we know we can't, so we have to borrow from the 3. We get 2. 2/10 and 10/100. 10/100 minus 5/100 is 5. 2/10 minus 1/10 is 1/10. Bring our decimal down and a 0 if you'd like to. And your answer is 15/100 for example number 4. This was practice problem A. All right, let's look at example 5. We don't have a fifth example. Okay, we don't have a fifth example, but we're going to do practice problem K for example 5. Anissa poured 1.2 or 1 2/10 liters of cranberry juice from a full 2-liter container. How much cranberry juice was left in the container? Show your work. Okay, so I guess if you'd like to, I'm going to draw a very, very nice bottle. This bottle has 2 liters of liquid in it. 1.2 liters was taken out of it. So how did we want to do this? Okay, 2 liters total. 1.2 liters was taken out of it. What do we have left over? Okay, I know that we need to take 2 liters minus the 1 2/10 liters to get our answer. We put our decimal place here. We add our 0 and we subtract. Borrow from the 2. 10 minus 2 is 8. 1 minus 1 is 0. Our answer for example number 5, how many liters are left from the cranberry juice? We know that we have 0 and 8/10 liters. And you'll put that one down for number 5. Don't forget to bring a movie tomorrow if you have a good one, and money for Powerade or an apple juice, orange juice. But remember, you cannot bring a pop. You can bring your own Powerade or apple juice or something from home, though. Have a great night. I will see you tomorrow.